Hi, welcome to the Bytecode Alliance community stream for May. I have three different speakers here with me today, one virtual, the rest are live, so please ask questions over in our Zulip community stream chat or on the YouTube comments. Our agenda is that we're going to talk about a new project that's been contributed to the Bytecode Alliance called Javi, work that's been happening within the WASM tools space to support a new syntax as part of the component model called the WIT include syntax, and another new project called Componentize Pi. Let's get started. First up is Javi. I'm going to bring Saul on stage with me. Hey, Saul, how are you?
Hi, Billy. Very good. How are you?
I'm doing great. Can you tell me a little bit about Javi, the new project that you've contributed to the Bytecode Alliance?
Yeah, sure. So Javi is a JavaScript to WebAssembly toolchain that was developed primarily by Shopify, and this grew up as an experiment to see if we could bring JavaScript on WebAssembly for Shopify functions. So Shopify functions is our kind of functions at the edge product where people can write custom logic and then we execute that on Shopify to modify business logic. So the idea here was to see if this was feasible, and it ended up being feasible, and it ended up developing into a project that it's now what some people know as Javi. So, yep.
So you have a lot of users, and I guess this means that it's basically used in production, is that right?
Yeah, that's right. So it's been used in production in a couple of places that I know, or at least last time I checked. Obviously, Shopify is the first adopter. Then Fermion uses it too for their JavaScript SDK, and also Suborbital. There might be other use cases that I'm forgetting right now, but yeah, we have quite some users for this tool. Yeah.
And now, within the Bytecode Alliance, this isn't the only project that's doing work to support taking JavaScript and being able to run it in a WASM module. Um, can you compare and contrast between, like, say, Javi and Jco?
Yeah, that's a very good question. So I think the main difference between these two tools is the underlying runtime that is being used. So for Javi, we use QuickJS, and for Jco, SpiderMonkey is being used. And the main difference is the module size that you're going to get once your final WebAssembly binary is being bundled. So our main focus for Javi since the beginning has been very small. So we optimize for small module sizes. This is important because some of the constraints that Shopify has in its own infrastructure. So we ended up optimizing for this a lot. And then I guess the other contrast here is how the engines behave themselves. Like QuickJS is a way less complex engine than a SpiderMonkey. So getting started with QuickJS was definitely easier than having to, get all the expertise to use something like SpiderMonkey. I guess that's the main difference, really. And then recently, the other thing to point out is that with Javi, we haven't started supporting the component model, which is something that Jco really has been doing from the beginning. We do have some plans potentially to bring the component model into Javi because it solves just a wide array of problems that you might encounter with performance. For example, one of them could be you might not want to consume a dependency to perform hashing, for example. With a component model, you can compose two modules and make your JavaScript module use another dependency from such functionality that was written in Rust, for example. And then that solves the problem of having to just use everything on JavaScript. So yeah, I hope that brings more clarity to the difference between these two.
Yeah, another cool use case that I'd love to see with Javi is if I do use the component model and I compose two components together, I would love to be able to use leverage the same embedded JavaScript engine, the QuickJS engine, so that I don't have like duplicate copies of that. Like if I were to do module linking versus component composition style linking. This is me just putting in a feature request, I guess, at this point, but I think it's really cool, and I love the fact that we've got another project that's being used in production within the Bytecode Alliance. And so if folks want to get started with Javi, where would you point them to?
So I guess right now the main place to go would be the repository of Javi, which is located under the Bytecode Alliance organization, Bytecode Alliance slash Javi. So maybe we can include that somewhere in the chat or in the presentation. I think that would be the best place. Right now we have a couple of issues that could be good for people to start out if they want to contribute. Yeah, we also accept feature requests if you're using Javi and want to see some improvements. We have been like quite constrained right now, but we are open to adding more features if there is an actual need to do so. Yeah.
Cool. And do you already have like a good first issue or tag that you use in the project? Or do you know of a few low-hanging fruit that maybe somebody might want to bite?
Yeah, I mean, we don't have a lot of issues open, like 16, so easily scanning, you could
Yeah.
see which ones could be the ones that you could take. But I think most of them don't require a lot of in-depth knowledge of the tool. I think it would be, yeah, any of those could be a good place to start.
Okay, that's great. Thank you so much for giving an update on it. I think it's a really great project, and I love that we're building a lot of different tools that give people choice so that they can choose if they're optimizing for a specific use case or for size. And having something that runs in production is just really powerful. So thank you, Saul. And stick around for the end where we can do some more Q&A. And if anybody has questions throughout the stream for Saul, I'll funnel them back to him live at the very end for the Q&A.
All right, thanks for having me.
Okay, next up is the wit include syntax. So I'll give you a quick overview. This is something that Joe's been working on for a while now. So within the component model, which is being designed within the W3C, a part of that is the wit IDL, and that's the way that we can define high-level types and interfaces to be able to have components that can link to each other and also be able to transmit types between the host and the guest boundary. Host being the host runtime and a guest being like the WASM component. Now, Joe has created something and proposed and championed a change to the wit syntax that is called include. And I'm going to play his video.
Hey everyone, my name is Joe, and today I want to talk about the WASM component model and the weights. The WASM interface type is an IDL or interface descriptive language for the WASM component model. In a weight, you can define interfaces and worlds. An interface defines functions and types corresponds to the component model definition. And the world is a complete definition of all the imports and exports of a component. And today, if you want to verify your weights or print out a fully resolved weights that has all the dependencies, you can use a tool called WASM tools component weight command, and then you send your weight file as an argument to this command and verifies it. People normally write a component by starting writing a weight and then generates the guest bindings, the host bindings. And when people write a world, they typically write something like this. This is a command world that has all the imports of YZ clocks, YZ file system, YZ sockets, and a single export of an executable running function. However, there is a second way to define a world, and this is called a union of worlds. So now imagine we have a worlds union file that has a bunch of interfaces and worlds. We have the world, we have a different world, and a test world. And now we can form a bigger world called the union world by including all of those smaller worlds. And what that means is it has all the imports and exports from those included worlds. So now if I show you by feeding this file into the component weight command, it prints out a fully resolved union world file definition that has imports and exports from all of the included worlds. And now you might be wondering, what if I have a world that includes other worlds, but they have the same imports and exports? Well, in that case, we have to do deduplicate. So let's see an example. We have my world A that imports A1 and B1 interfaces, as well as my world B that does the same thing. Now, if we included those two worlds in Union My World, well, reasonably there should be just one copy of A1 and one copy of B1. And this is exactly what happened here. If we run this command, and we'll see that Union My World has A1 import and B1 import. Now let's see something more complex. Suppose we have a YZ Cloud Core world that includes YZ HTTP that does HTTP handling, key value that acts as a key value store, and exchange messages through YZ messaging world, and upload files to a blob storage using YZ blob store world. And we can form this YZ Cloud Core world the application can target to by including all of those smaller worlds without having to copy paste all the imports and exports from those smaller worlds. If we fully resolve YZ Cloud Core, you'll see this enormous YZ Cloud Core world that imports all the dependencies of this individual world from YZ HTTP or YZ key value, deduplicates, and having all of the imports and the exports lined up in this YZ Cloud Core.
Wow, that's good. So great. I'm going to share a link to the Joe's work here in the WASM tools repository. That's where a lot of the implementation for things like the parser is added, and so that if folks want to start using it, you need to use that PR. I don't think it's been merged yet. I need to double check. But it's really exciting for me because that means that we're able to do things like standardize the HTTP proxy world independent of the WASI cloud world core file. So the idea is that with these two different worlds, we're able to kind of define the way that you want to take a WASM component and run it in that specific platform or in a world, right? It's really hard to talk about world files without going into the cheesy intro to any different movie. But I'm really excited about that, seeing that land. That's one of the last remaining WIT syntax changes that we know is incoming before WASI Preview 2 enters into draft. So thank you, Joe, for sharing with us. Up next is Componentized Pi with Joel Dice. Hey, Joel, how are you?
Doing well. How are you, Bailey?
Doing good. Can you tell me a little bit about Componentized Pi?
For sure. Yeah, to set some context, earlier Saul alluded to the desire to create essentially polyglot components. So the idea that you could have one part of your application written in JavaScript and maybe another part written in Rust and maybe a third part written in Go. Each of these languages have their own ecosystems and their own sort of strengths, especially, in the Python world, it's data science, it's machine learning. In Go, it's cloud microservices. In JavaScript, you've got request routing in the Node.js world, et cetera. So you've got kind of best of breed libraries in all these ecosystems, and ideally you could combine them without regard to the specific language that maybe you're hosting them in. And so, for example, you might want to build a guest component that's a composite of a TypeScript, Rust, and Python subcomponents, and then host that in Go. There's no reason you shouldn't be able to. But a prerequisite for making that happen is we need tooling to support both hosting components from within a variety of languages and also building guest components from within a variety of languages. And it turns out that Alex and others at Fastly have already brought us WASM-Time Pi, which allows you to run components, host components from within Python via these WASM-Time Python bindings. Really cool technology. Up until now, though, there wasn't a way, at least not an easy way, to construct components using Python, so guest components using Python. And so that's what componentized Pi is intended to do. And so it does that using essentially two steps. One is synthesizing Python bindings from WIT files, those same WIT files that Joe just showed us. And the other is to bundle application code that you've written to target that world, to use those interfaces, those generated bindings, and bundle those with an embedded CPython interpreter. And altogether, that creates a component that you can run on any component compatible runtime, including time wasm time pi, or the Rust version of wasm time, or the Go bindings for wasm time, etc. And so, this should sound somewhat reminiscent. It's kind of similar to Java, although Java hasn't really embraced the component model yet. You can look at JCO and componentized JS. Componentized Pi borrows techniques from both of those projects to achieve its goals. And also in terms of prior art, there's on the browser side, Pyodide is a really cool. If you're in the Python world and you've experimented at all with WebAssembly, you've probably heard of it. It's basically a one-stop shop for embedding Python code in browser and interacting with the JavaScript ecosystem there. So it's the componentized Pi. It's inspired by all these things. It's usable today, insofar as the component model itself is usable. Of course, it's undergoing rapid changes, as we speak. But looking very much forward to when Preview 2 of WASI stabilizes, and we'll have stable system interfaces for interacting in cloud environments, in browser environments, and so on. So that's kind of the high level view.
I love it. Thank you so much for that. How many people would you say have been collaborating around trying to get the component model working with componentized Pi or just Python in general?
Yeah. So far, it's mostly me behind componentized Pi itself, with a lot of input from. I've been leading a subgroup of what we're currently calling the SIG. Dynamic languages group, soon to be renamed to, I think, SIG guest languages. But we've got a subgroup about Python and have gotten input from Brett Cannon, who's a very well-known contributor to the Python ecosystem. And I'm actually going to speak with Hood Chatham later today of the Pyodide fame, and try to build a little bit more cohesion across the browser ecosystem and the other places we want to run WebAssembly. Also, Kevin Smith from Single Store, Kyle. I forget the
Kyle
gentleman's
Brown
last.
from Single Store as well. Yeah.
Thank you. Yes, last names are hard. And so I've gotten input, and then also I do want to mention the big next step here. As you may know, the Python ecosystem is heavily dependent on native extensions written in other languages like C and Fortran, NumPy, Pandas, SciPy, etc. And currently, componentized Pi does not yet support native extensions. That's the next big priority, and we're making great progress. And I want to, in particular, call out Jamie Sharp, Dan Goman, Alex Crichton. They've all been extremely helpful moving us towards that goal where we can transparently pull in those native extensions as part of the componentization process, and use those transparently. So that's really exciting.
Yeah, I've really enjoyed your updates during the component model weekly calls where you've described some of the techniques that you've had to discover and use to be able to do things like pulling in native extensions, which is pretty different from a lot of the other languages that we've tried to componentize at this point.
Yeah.
Is there any other tricks you want to share about how that works?
I mean, it's the term we're using is shared everything linking. Dynamic linking is a little bit misleading. That's certainly what Pyodide is capable of doing via the mscript and toolchain in the browser, where it can literally download a WebAssembly dynamic library at runtime as needed, and essentially leak it into a running application. In the cloud computing, that's not necessarily desirable. It's not off the table, but it's not our first first priority. Instead, what we're trying to do is what I would call just-in-time prior to instantiation linking. So the idea here is that we would be able to pull in a dynamic library just prior to instantiating so that WASM time, for example, and other runtimes, which want to have the entire module, the full code available to be compiled to native code all at one time rather than sort of incrementally, so that this sort of linking paradigm would fit into that ahead of time compilation paradigm. So the idea would be that you would have your application, which may depend on, and this sort of goes back to what you were asking about with Java, um, uh, uh, have an external dependency to the CPython interpreter, and then also perhaps one or more native extensions such as NumPy, and be able to pull those in, generate a component that links in those modules, and then feed that to WASM time, and then instantiate that and go ahead and start calling functions on that component. And the intention is that this whole mechanism that I just described would not be Python specific. That's certainly sort of our headline use case, but that it would actually be usable in any language, dynamic or otherwise, that have existing sort of shared everything libraries where you actually want to share memory, you want to actually pass pointers around, wherever that would be useful. We'll be able to support that.
Wow, I love it. I love the detail. I guess that's part of the cool thing about the Pyodide library itself today is that they've figured out how to compile a lot of the different Python dependencies that are out there. I remember I think NumPy might actually be compiled through Fortran, or at least has some Fortran dependencies. So can you talk a little bit more about like what's the game plan for pulling over some of these other libraries?
Yeah, well, I mean, the good news is, yeah, the Pyodide folks have sort of paved the way for us. So we're going to, and in fact, this shared everything linking mechanism I just discussed literally reuses the convention for dynamic linking. So in theory, the same files you're using in the browser with Pyodide should be linkable in this scheme for cloud use. I actually haven't dug deep into how they're building Fortran code to WebAssembly. I know there's a few projects out there for LLVM to compile Fortran. So I imagine they're using one of those, but I don't want to go out on a limb and speculate. But I'm heartened by the fact that they've solved a lot of these tough problems already, and we can kind of build, stand on the shoulders of those giants and build forward. So.
Yeah, I love it. And one of the things that I really appreciate with what you've been doing leading this project is reaching out to upstream, working with the Python folks and the maintainers, and finding ways that we can fit within existing ecosystems and tools. So thank you so much for all of that work. I think we have one more item. And folks, if you have any questions, please ask them in the YouTube chat or in the Zulip channel. And Joel will stick around for the Q&A right at the end, but we have one last item, which we kind of snuck in at the last second, and I'm going to ask the Executive Director for the Bytecode Alliance to talk to it. Hey, David.
Hey, Bailey. Yeah, we snuck it in at the last second because there's really sort of a you heard it first late breaking news thing going on. So at the end of last week, the Linux Foundation, which runs a global series of events to bring open source technologists and leaders together, announced their first foray into the WebAssembly space. They announced an event they're calling WASMCon as an opportunity for us to bring WebAssembly technologists, community folks, developers, people just curious or maybe wanting to learn more about WebAssembly and get started all together for a 2-day event. It'll be this September 6th and 7th in the Seattle, Washington area. The announcement for the event went out last week. The website is up. There's the link. The call for papers is there. Registration information is there. There's a very broad scope for the event. We'd love to have deep technical talks, some of the things, the project work that Saul and Joel have just described, a lot of the other things that we hear about on the great community streams. Thank you for hosting them, by the way. And hands-on workshops, panels, technical. We're really looking for a breadth of content. The Bytecode Alliance is happy to be a community sponsor and help organize the event. We're going to sort of plug in and be part of the program committee, getting the word out, engaging all of our communities and projects. And so love for people to check out the website, look at the information. There's a whole list of suggested topics. People have maybe like to submit a paper or a panel idea, or even sort of think about hands-on workshops that would be great for us to do, because we're looking to get all of that kind of content over the 2 days of the event, Wednesday and Thursday, September 6th and 7th. Check out the website. And if you have any questions, just let us know in Zulip. Happy to help people get more information. Also, the good news, you don't have to be present to win. A lot of the sessions and content will be streamed live. They'll be recorded so people can watch them later or time shift them if they're in another time zone. So really eager to use the event as a forum for bringing people together, working and learning together, and then helping us get a lot of the good word out about WebAssembly and the communities that are active around it.
Wow, couldn't have said it better. This is perfect. So please submit. I can't wait to see everybody's talks. And yeah, I'm going to do everything I can to be there in person. I'm so excited to have another WebAssembly specific conference. After WASM.io, that was in Barcelona, that was a blast. So I'm
And to
hoping we
give
get
people a
the same
little
vibe.
information to plan from, the call for papers is up through June the 25th. And
Mm.
information for submitting paper ideas is on the website. The paper submissions will be worked through by the program committee, and folks will be notified by July the 18th. The schedule will then go out very shortly thereafter, and we'll have other details about the event, the facilities, hotels, etc., all available on the website.
Great, great. Thank you, David. If you don't mind, you want to stick around and hang out for a panel for Q&A? All right,
Sure,
cool.
happy to do that.
So now we're in Q&A. I'm going to bring in everybody back. Let's see. Maybe I can make us all and get rid of this. Okay. All right. Hey, we're hanging out. Do we have any questions in the stream? Has anybody asked anything? Curious about some of the work that's going on. Joel and Saul work in a lot of different areas beyond just those projects. So you can kind of ask them anything, I feel like. Between the two of them, you've got like a guest languages expert, and you've got somebody that's been deep within the Wasmtime repo. Saul's been here talking about Wiser before on the community stream, so I'd say everything's fair game. All right, everybody's asleep on the West Coast, I think. But where are you, people who are in Europe? You should be awake and have plenty of coffee at this point. That's okay. I've got at least 2 questions that I've been wanting to ask. Saul, what is the most exciting thing beyond let's not talk about components. Let's talk about like what's the coolest, most exciting feature that you plan to see with Javi? Perhaps maybe it's like a use case for Shopify, or just something that you've been imagining that's a crazy big idea.
Yeah, so I think the biggest thing that I wanted to see is composability. I think that comes from the roots of Shopify's environment being like really constrained in terms of performance and module size. So earlier, I think I presented this idea before components were like very, very strong as they are today. There was this tool called WasmLink, and so I took that tool and I composed a JavaScript program and a Rust program to see what the performance characteristics were going to be, and that was just very mind-blowing on the things that you could do, right? So I think getting to that level of composability is one of my dreams, really, to make sure that you're not constrained by the language of that you're choosing, and that you can work at the WebAssembly level more than at the source language level to do those kind of optimizations.
Yeah, I think it's going to be a major game changer for the software industry. So it's obviously one of the things that I'm most excited about right now. And if folks want to watch another talk that goes a little bit more in depth about some of the tools that we've talked about, Guy Bedford and Peter Hune gave a talk at WASM Day where they showed off some of the tools that they've been working on and gave a live demo where Guy coded up an app in, I think it was Svelte, but JavaScript, created a JavaScript component that then Peter was able to pull down from a registry. I think it was a local registry, but a registry nonetheless. And he was able to take in Guy's component and then compose them together. And so we had Rust and JavaScript working together, which is, yes, mind-blowing. We actually have a question on the stream, so I'm going to bring it up. So this is from Steven, and he's asking if Javi is maybe something that's like FAS for Shopify, or is it like a component plugin? Can you describe how it's being used?
Yeah, so right now it's no longer Shopify specific. So to bring it to the Bytecode Alliance, we've removed everything that was Shopify specific and leave it as a generic JavaScript on WebAssembly runtime. But yeah, it's used at Shopify in functions as a service. Sorry, in functions as a service way. So if you want to use JavaScript as your language to extend Shopify, you could write your programs in JavaScript and then submit your modules, and then that's the program that gets executed if you want to extend some part of the business model inside Shopify.
Joel, are you game to answer this question from Steven? So we've been using the word bundle, and I know the answer here is a little bit complicated because there's lots of ways to answer it and lots of different ways to solve this type of problem. But do you mind giving just a few off the top of your head?
Yeah, so yeah, this also sort of calls to mind the Docker ecosystem where you have a mix of static and executable content that you're delivering. And so the component model is definitely intended to be able to support those use cases where you have like non-executable, whether it's images or HTML or CSS, embedded as part of your deliverable. That is actually something that we're actively working with. It looks like we're looking at bringing WASI VFS, which is a virtual file system layer, into the Bytecode Alliance. It's been a third-party project for a while, and updating it for use in the component model. We've been talking about exactly how that would work. And I think part of the vision would be that you would be able to essentially build a component with an embedded, essentially virtual file system, which would potentially be layered on top of a real file system if you needed actual real file system access at runtime. That would give you access to those resources. And so, for example, you could create a full stack app that does, perhaps some server side rendering, but then also on the client side does rendering as well. And that would involve some mix of static assets, some mix of executable WASM, some WASM that might actually not be run in the cloud, but actually be run in the browser. That is all part of the vision of what components could be, that they could contain that mix of sort of static assets and executable assets.
And I've also seen where folks have used WASI VFS for working within the Python ecosystem, separate from componentized Py, but as kind of like a stopgap. So they were able to bring in the CPython interpreter, and then within the WASM module, they basically stored the Python scripts that they wanted to execute. I've seen that also with JavaScript and others. So that's another way that you could talk about bundling. The answer here is that there's a lot. There's a lot that we can talk about. There's also data segments within. I believe that's part of the core WASM module spec, and we've also talked about within the component model in the future being able to support streamable data segments. So if we do this type of bundling that Joel was talking about, we could even bring in things and kind of like load them after the module's already been instantiated, so we don't have to wait for all of that to be downloaded. That could be really powerful too, especially for some of the use cases that Joel was talking about in Python. Hey, we've got another question. This one's for you, Joel. When talking about Python native extensions, you mentioned this could apply to other languages. Can you talk a little bit more about how other languages may reuse that same approach?
Yeah, for sure. So the intention is that any language that has sort of a foreign function interface layer, Java has JNI. I'm not familiar with all the language ecosystems out there, but I assume Ruby has a way of getting at that. And certainly we've been talking about Python. Any of these higher level languages that want to access and reuse libraries written in, say, a lower level language, say a compression library or a video codec or something like that. Traditionally, the way that worked in a native environment was you would pull that in as a shared library, and each language has its own sort of syntax for doing that. So the expectation is that you would be able to do that as you migrate to the WebAssembly world and the component model. You would be able to kind of take those libraries with you, and so again, you're just using a compression, say the Z standard compression library written in C, but also has bindings for just about every language out there. Really great algorithm. The idea is that potentially the publishers of the Z standard library, the maintainers, would be able to publish a mscripton / WASI shared library, which is in fact just a WebAssembly module that imports a memory and without getting into too many technical details, then is linkable into any component tool, such as componentized Pi, and we expect that these to proliferate and be linkable in that sort of just-in-time, just prior to instantiation way that I discussed, and that should be true for Java, for Kotlin, for Ruby, for Python, etc. So it's all based on and inspired by existing native library linking approaches, such as what Elf or Mako, or if you're familiar with portable executable on Windows. All of these have sort of converged on a similar feature set, and we're essentially embracing that at the WebAssembly level as well.
Wow, awesome. Do we have any questions over in the Zulip chat, David? Do you see any? Okay. At some point, I will. I should have created a topic over there, but that's okay. David, what you've been paying attention to the space for a while, right? And what are you most excited about? Maybe perhaps what we're going to see at WasmCon, September 6th and 7th.
Yeah, well, it's early in the conversations. Good question, Bailey. Early in the conversations about WasmCon at this point, but I think one of the things that came together as we were talking with Linux Foundation folks and the Bytecode Alliance board and some of our community members was the opportunity to showcase the breadth of the applicability of WebAssembly. We talk a lot about cloud and sort of extensive architectures that are capable of running, as Joel was just describing, rich heterogeneous sets of components, all in different languages, all composited and sort of safely executed in a very persistent and omnipresent kind of way. And I think that's great. The other piece of this that we've sort of drawn out or expected to maybe try and highlight a little bit more at WasmCon is the broader deployment environments that you can see, embedded use cases, for example. There's a lot of interest among Bytecode Alliance member companies in using WebAssembly in the small. And we've talked about it here on some of the community streams with the presentation on Whammer and others. And so I think there's tremendous attention in trying to have the breadth of the applicability of WebAssembly be something that we can showcase for everybody at WebAssembly and bring together people and then also sort of cross-train and cross-pollinate some of these discussions, because some of the things that people want to do on embedded today sound like what we were trying to figure out how to do with JNI and other things many years ago, in the cloud or on servers somewhere. And so I think really giving people an opportunity to mix and match across those environments and go from really small systems to really big ones and have all of that in play in a conversation around a unifying technology like WebAssembly, I think there's a lot of excitement, and we're sort of hoping, hint, hint, that we'll see a lot of content kind of across that breadth of use case.
Yeah, I love it. And another way that we talk about being able to run something that's tiny that can also run at scale in the cloud. Some of the ways that we see that working is with virtual platform layering. And I had the opportunity to hang out and chat with Luke Wagner Friday, maybe 2 Fridays back, where we just recorded a stream and I picked his brain about all the different use cases that we expect to see there. So if you're interested in that, do check out that stream. And that's related to this other question that Steven's asked, which is, are there any caveats with WASI VFS when it's attached to a network file system? So right now with WASI VFS, this is kind of like virtualized. It's like embedded inside the WebAssembly component. It's not attached to network or anything like that today. When we're talking about being able to virtualize different things with different platforms, that will be enabled likely through the host implementation. The host will provide that type of capability. And so there's no reason to think that the host doesn't have the ability to work with the network the way that it needs to native to its system. So I don't foresee any caveats, but hey, network and file I/O, maybe avoid it if you can. It's probably my pro tip there. Anything you would like to add, Joel or Saul, for that one?
I think you pretty much summed it up there. Yeah, it's really, you can, similar to in the container ecosystem or the virtual, the kind of virtual machine ecosystem, you have this idea of mounts that you can basically specify when you're instantiating, whether it's a container or a VM or whatever. And that mount is generally a host directory. And that host directory could be a mount of, an elastic file system or an NFS mount or whatever. At the guest level, it shouldn't care. It's all just a POSIX file system or a WASI as POSIX file system. So I don't anticipate anything that, if there was a problem, I would imagine it would affect containers and virtual machines as well, if that makes sense.
Yeah, that's a good way to put it. Okay, I don't see any more questions coming in. Did you guys have questions for each other? I feel like I every time I get to do this, I just like get to pick everybody's brains and nerd out, and I have a good time. And I feel guilty. I feel like I get to monopolize you. So if there's anything you wanted to bring up or say before we end the stream, now's your chance. No. You guys are shy. Okay, well, I had a great time, and I really appreciate you taking the time to share your work that you've been working on within the Bytecode Alliance, and I hope all three of you, the work that you've been putting in is something that everybody's going to be able to build on top of. It really does feel like all of these different pieces of the system, including events and community organization, is building that software foundation, the promise that we've been trying to do with the Bytecode Alliance. So thank you. And with that, I'm going to end the stream. See everybody next time.